Holothuridians, also known as sea cucumbers, often have a bad reputation as being dirty and slimy creatures, but they're actually a delicacy in many Asian cultures. Some species have been sold for as much as $150 per kilo, which may be because some people believe sea cucumbers promote men's sexual health. You know, because they resemble and sometimes behave like a certain male organ. Regardless of the reasons, with such a high demand and value, they're a profitable choice for aquaculture. I'm going to review some of the general techniques used to culture sea cucumbers from the broodstock to grow-out phases and explain potential issues like disease, and I'm also going to discuss their current and potential roles in polyculture systems. Only the highest valued species are cultured on a commercial scale, which mainly includes the Japanese sea cucumber and the tropical sandfish. Culturing of both of these species began in China and India in the early 80s and has since spread throughout Southeast Asia and the Pacific Islands. For most hatcheries facilities, the broodstock is collected from the wild and then kept in seawater tanks at a density of around 30 individuals per square meter. They're left to acclimate for about a week before spawning is induced by one of two methods. The first, which seems a bit inhumane, involves letting them dry out and then blasting them with a stream of violent water. Luckily, the second method is preferred and uses a temperature shock and sometimes some spirulina to set the mood. Spawning usually occurs in the middle of the night when it's dark and quiet, and the male's role looks a little something like this. Once the spawning is over, the eggs are washed and fresh seawater is added and kept at around 22 degrees Celsius. The hatch rate is usually as high as 90%, and the successful larvae are then transferred to a separate rearing tank. Once the mouth has developed, feeding must begin immediately. They start out on a diet of mixed microalgae species, which are cultured on site. After about a week, they begin to settle onto devices that are placed in the tank and made up of plastic screens. It takes around 2 weeks to develop into the juvenile stage, and the diet shifts to include diatoms and sargassum, as well as yeast and artificial feeds. 2 to 3 months later, the juveniles are finally ready for grow-out. Throughout this process, the optimum water temperature is between 23 and 25 degrees, with the salinity around 31.6 and pH at 7.8. In China, most grow-out facilities are extensive pond systems and are usually just old prawn farms. Sea cucumbers are stocked at a density between 30 and 100 individuals per square meter. Even with extremely low pond maintenance and little to no feed, the sea cucumbers typically grow 1 to 1.5 times faster than they do in the wild. More intensive systems and sea pens are sometimes used, but they're not popular because they're so expensive. The adults are harvested after 1 to 2 years and grow out and sent to processing. Sea ranching is becoming popular in regions where wild stocks have been heavily depleted, such as the Pacific Islands and Australia. Diseases affecting sea cucumbers include the bacterial ulceration syndrome, which can wipe out about a third of the stock. Even worse is a parasitic disease that can have 90% mortality rates and basically disintegrates the sea cucumber. Most of these diseases can be prevented by using high-quality food and water and occasionally antibiotics. Since sea cucumbers are detritivores, they'll eat pretty much anything off the bottom of the pond, including waste from other species, which is why they may be ideal for polyculture systems. So far, the only commercial-scale co-culture of sea cucumbers is at prawn farms in China. Experimental trials with finfish species such as salmon, barramundi, and pompano, and bivalves such as the green-lipped mussel have shown a lot of promise. Expanding polyculture practices and closing the life cycle for other important species, like the Australian sea cucumber, seems to be the future for sea cucumbers in aquaculture. These dirty delicacies just might help other aquaculture systems become more sustainable and environmentally friendly.